Hashtag new laptop processors compared long-form tutorial script. You're probably picking the wrong processor for your next laptop, and you don't even know it. Most people just look at the number Intel Core i7, AMD Ryzen 9, and assume bigger number means better. But that's leaving performance on the table. Today, we're breaking down exactly how to compare 2025's newest laptop processors so you actually get what you need. Here's the thing, processor choice determines everything. Your battery life. Your gaming performance. Whether your laptop handles video editing or just struggles opening Chrome tabs. So let's get this right. When you're shopping for a new laptop, you'll see three main players: Intel's latest Core Ultra series, AMD's Ryzen 9000 mobile processors, and Apple's custom chips if you're in the Mac ecosystem. But here's what matters, the specs that actually change your experience. First, let's talk cores and threads. Open up any processor comparison page on Intel.com or AMD.com, and you'll see these numbers. Cores are like workers in a factory. More workers, more work gets done simultaneously. The newest Intel Core Ultra processors offer configurations ranging from 10 to 16 cores, while AMD's Ryzen 9 series pushes up to 16 cores in mobile form. But here's the secret: more cores don't always equal faster speed for everyday tasks. A 12-core processor with higher clock speeds will crush a 16-core processor running slower if you're just browsing and emailing. Clock speed, measured in gigahertz, that's the speed each core operates. Look for base clock speed versus boost clock speed. Base clock is what you get all day long. Boost clock is the sprint when your laptop needs power. Per recent processor documentation from Intel and AMD, modern laptop CPUs typically base at 2.5 to 3.5 GHz and boost to 5.0 to 5.8 GHz. That boost speed matters for video exports, rendering, gaming sessions. Now, thermal design power. That's your TDP number, measured in watts. This isn't about how hot the processor gets, it's about power consumption. A lower TDP processor means cooler operation, better battery life, thinner laptop designs. AMD's newest processors hover around 28W to 45W for efficient models, while Intel's Core Ultra series ranges from 10W to 55W depending on configuration. Don't ignore this number. It directly impacts whether you're hunting for a charger every 4 hours or lasting a full workday. If you're finding this valuable, hit that subscribe button. We post tech tutorials daily, and staying updated on processor tech will save you hundreds on your next laptop purchase. Let's get into architecture. This is where generational leaps happen. Intel's Meteor Lake architecture, their latest for thin laptops, focuses on efficiency cores and performance cores working together. Think of it like a smart team. Efficiency cores handle background tasks and emails, performance cores wake up when you need power. AMD's Zen 5 architecture, found in their latest Ryzen 9 series, emphasizes instruction per clock improvements, meaning each core does more work per cycle. Check the architecture specs on the product pages, this determines real-world responsiveness. Cache size matters too. This is like your processor's short-term memory. More cache means frequently accessed data loads faster. L3 cache is what you want to compare. The latest Intel processors max out around 36 megabytes, while AMD's Ryzen offerings go up to 32 megabytes. For everyday use, the difference is subtle. For content creators and developers, larger cache reduces lag when working with huge files. Here's the practical part: GPU performance. Every modern laptop processor includes integrated graphics. No separate graphics card? Your processor's GPU handles gaming and video editing. Intel's Iris Xe graphics, check their specifications page, offers solid 1080p gaming at medium settings. AMD's Radeon graphics and Ryzen chips compete directly. If gaming matters, compare GPU specs as seriously as CPU specs. These aren't afterthoughts anymore. Power efficiency rating, look for this on official specification sheets. Some processors deliver more performance per watt. Per latest manufacturer documentation, newer architectures achieve 15 to 25% better efficiency than previous generations. This translates to real battery life. If you're choosing between two similar chips, pick the one with better efficiency ratings. Your battery will thank you. Now the pro tips. When comparing processors, use benchmark sites like TechPowerUp's CPU database. Run the actual numbers, not marketing claims. Search for your specific processor model, you'll see single-thread performance and multi-thread performance scores. Single-thread matters for snappy response. Multi-thread matters for heavy lifting. Most users prioritize single-thread in battery life over raw multi-thread power. Prioritize accordingly. Check release dates. Newer isn't always in stock. According to recent market data, sometimes last-generation processors offer similar performance at lower prices. Sometimes the jump is worth the cost. Know what you're paying for. Watch thermal management. The best processor in a poorly cooled laptop will throttle down, losing performance. Check reviews mentioning fan noise and heat management. Slim laptops often sacrifice cooling for thinness. One more thing, software optimization. A processor's real-world speed depends on how software uses it. Apple's chips run optimized macOS software. Intel and AMD processors depend on Windows optimization. This can account for 10 to 20% performance differences you won't see in raw specs. When you're ready to purchase, use the processor comparison tools on manufacturer websites. Intel's and AMD's sites have filters and comparison charts. Plug in your real-world use. Are you coding? Gaming? Video editing? Content creation? Each workload benefits from different processor characteristics. Coders love single-thread speed and responsive cores. Creators love multi-core power and cache. Gamers prioritize GPU performance and consistency. Here's your decision framework. Budget laptops prioritize efficiency cores and battery life. Mid-range balances performance and price. High-end goes for peak performance and all-day reliability. Your budget determines your choices, but now you know what specs matter within your price range. The biggest mistake? Buying based on model numbers alone. An i7 from this generation beats an i9 from 2 generations back. A Ryzen 7 with better architecture beats an older Ryzen 9. Always compare specs, not just names. As you navigate your tech journey with confidence, remember, the right processor isn't the most powerful one, it's the one built for what you actually do. Whether you're a student, professional, creator, or gamer, you now have the framework to choose wisely. Don't let processor specs confuse you anymore. You've got this. Make sure you're subscribed so you don't miss our next deep dive comparisons. We'll keep breaking down the tech that matters so you can make informed decisions every single time.